We were talking about different aspects of the wireless LAN. Now we will talk about a particular case that is use of the wireless LAN infrastructure mode with typically several access points used. And in that kind of infrastructure, in that kind of wireless LAN, we could support the mobility, the roaming of the stations, and typically a mobile station. It could be a phone, a smartphone, or it could be a laptop, a notebook. And then a mobile station could be connected to the network, to the wireless network, and even if the zones, the areas that by which the mobile station is moving are different and covered by different access points. In this typically in this picture, we could see the different areas covered by different access points, and the mobile station that is traveling, is moving from one cell to the other, and we would like to be connected all the time, and each time we left a particular cell and reach another cell where the access point is different, and then we could detect this change by the measuring the detection of the carrier, the signal carrier of each access point and the other stations in that area, particularly the access point. We are talking about an infrastructure, the case of infrastructure basic service sets. Then this is possible using this standard, and the prerequisite is all access points are directly connected to each other across a network like this here. That is, for instance, a switched Ethernet network that is cabled, typically with twisted pairs or fiber cables. Then we interconnect the access points with that kind of backbone network, and provide wireless service across those access points to the different stations. The mobile station then measure the received signal strength, what is called the RSSI, that is received the signal strength indicator of the access point. If this RSSI is too low, it looks for a new access point. The looking for a new access point could be performed passively, typically scanning the carrier signals and listening the frames that the access points are sending, or an active scanning, sending a sample request frame in order to test the quality, the presence, and the quality of the signal the carrier transmitted by the other the different access points. If a new access point is found, with a better RSSI. The mobile station registers, we will see which are the frame types that are exchanged in that case, and the new access point informs to the old the former access point about the change. And in this slide, we could see typically an example of what we call handoff. That is in the roaming process. This is called handoff between when typically a mobile station that was associated with, for instance, this access point, select another access point. The selection is based in the level of the RSSI, the indicator of typically the received signal strength of each access point. Then typically the mobile station will send an authentication request to the new access point. The new access point respond with an authentication response. This is typically the process of authentication. This mobile station need to be authenticated with the new access point. Once the access point admit this mobile station, in fact, the mobile node, the mobile station, exchange that kind of frame types, reassociation request. When the reassociation request is sent to the new access point, the new access point will send to the old access point. And this kind of frame type, send security block, receive and acknowledge security block, and notify the move to the old access point. And after that, then the reassociation response is sent from the new access point to the mobile station. Well, typically this is an example of handoff, but in fact this happens each time the mobile change from one cell to other cell. And this could be very useful, for instance, if we would like to support, for instance, telephone IP phone communications using mobile stations, typically mobile phones, and permit that the communications continue to be established even when the mobile change from one cell to the other. This is similar to the process in the cellular phone networks, but the cellular phone networks are more complex than the complexity used in the wireless LAN networks. Well, finally, we could talk about the addressing aspects. Remember that the MAC frame used by the wireless LAN technology has in fact two flags. One flag called 2DS. DS comes from distribution system, that is an access point typically. Then 2DS from DS in order to indicate if the frame is sent to an access point or sent by an access point. And after that, there are 4 addresses. Remember that the 4 addresses fields are addresses, in fact, of 48 bits, that is 6 octets. Why? Because all the addresses, in fact, are MAC addresses. Even in some cases, we use the BSSIDs, that is the Basic Service Set Identifiers. Remember that the BSSIDs are different from the SSIDs. The SSIDs typically are strings of characters that could have a length of 0 to 32 octets. That is 0 to 32 characters. But in this case, we use typically, once the access points are the stations are authenticated and admitted by the access point. Typically, the access point the protocol use the basic service set ID that is in fact a 48-bit long MAC address. And then, when, for instance, in the case 1, for instance, when a frame is sent from a station to another station, that is not a frame sent to or received from an access point. Typically, in the case of ad hoc mode, in fact, in address 1, we specify the recipient MAC address. In address 2, we specified the sender MAC address, that is then the source address, the destination address, and in address 3 we specify the BSSID of the cell. In the case of working with infrastructure mode networks, typically when we use access points, then the access points in this case are referred as distribution systems. Then typically we have 3 cases. One case is when the frame is sent by the access point. Then the access point send a frame to a station. Then the recipient MAC address is just address 1. The BSSID of the cell is the address 2, because in fact is the access point that is sending the frame. But in fact, the access point sent the frame that was transmitted to this access point by this MAC address sender specified in the address 3. Then this is the case that here we call case 2. In the case 3, then, is a typical case where the sender is a station that send a frame to the access point, that is to the BSSID of the cell. But the objective is that that frame is designated to this MAC address, this recipient MAC address. Remember that in an infrastructure mode, the communication between the stations are always via the access point. And finally, sometimes the communication could be performed typically between access points. Then is the case 4. Then the frame comes from an access point. It goes to another access point. Then the sender is the typical the address of one access point. The address one is the address of the other access point. But in fact, behind this, we have a sender in the address 4 and the recipient in the address 3. Always the access points are considered in those cases as intermediary devices, not end systems in the exchange of the frames. Well, we finished talking about the different aspects of the technologies, the wireless network technologies. I hope that now you know the basic principles of wireless communication and the task of the antennas. You can adjust the free space attenuation, the free space path loss at a given frequency and distance. Remember, if the frequency is higher, the attenuation is higher. If the distance is higher, the attenuation is higher. And then you could calculate which is the attenuation based on the frequency used and the distance between the antennas. You know the units dB. dBm is this is a relative unit, and this is in fact when the decibels are referred to an absolute power measured typically in milliwatts. And you know the spectrum used for wireless communications. Typically, we talk about the unlicensed frequency bands. You can explain the difference between ad hoc mode and infrastructure mode. Typically, ad hoc mode is, for instance, when we offer with our phone, mobile phone zone, a Wi-Fi zone. This is typically an ad hoc mode, and infrastructure mode is typically when we use one or more access points. You are familiar with the different standards according to this IEEE 802.11 standard family. You can explain the hidden station problem and the exposed station problem, and you can explain the access procedure CSMA-CA of wireless LAN with distributed contention function, and the use of request to send, clear to send, in order to improve the access procedure, the access algorithm, in order to reduce the probability of collisions. You can explain the CSMA-CA access procedure of WLAN using the point control function or point contention function. You can explain the process of roaming on Wi-Fi. You know the basic structure of a framework, of a frame for wireless LAN. Remember, the frame is slightly different compared with the Ethernet frame. Remember, there are some different fields. For instance, instead of 2 addresses, for source and destination addresses. There are 4 addresses, and there are typically a lot of control and management fields. You can explain the addressing then with the 4 addresses field, and you are familiar with current technology for wireless communication and can classify them in terms of range and data rates. Not only the Wi-Fi technologies, but for instance, other technologies like Bluetooth or, for instance, WiMAX, at least in order to have an idea of distances, data rates, and costs. Well, thank you very much.